we doing for time? 10 minutes. All right. So let's talk about how we're going to do our rotations. All right. What we're going to do is we're going to identify some edge that we want to rotate. All right. So, and what is that edge? Well, it's going to have some node and some parent. Right. So here's 5 is some node and 10 is its parent. Or if this was the edge, 10 is some node and 5 of its parent, right? And then you say, well, who hangs off of these nodes? Well, there are 3 places to hang off, right? Everybody buy that? And what are the values here? Well, everybody here is smaller than 5, right? Just like who's over here? Everybody here is smaller than 5, right? What about these guys? All of these guys are bigger than 10. What about here? All of these guys are bigger than 10. What about these guys? Well, these are bigger than 5 and smaller than 10, right? What about these guys? These are bigger than 5 and smaller than 10, right? Does that make sense? So these are both, this tree is the same as that tree, right? We haven't modified things in the side. A rotation, we have a right rotation that turns this into that, right? And similarly, you can go the other direction. You can take this and turn it into that, right? Does that make sense? So you're rotating it one way or the other. And then you look, what does that do to the height? Well, these guys, do they move? They don't move at all, right? They're the same height. But this guy, if he's too long, he gets 1 shorter. And the 10, if he's too shorter, he gets 1 longer. Right? Everybody buy that? The advantage of this rotation is it made this one smaller and this one bigger, right? And if so there is all this code, and if somebody wants to compile it, I could give it to you, compile it, and you can walk around this tree, and then you can say, pivot it here, and you can pivot it, and you can do all these pivots, and you can turn it into any tree you want. Right? Everybody good with that? All right, we're probably, right? So that gets, right? And that stays the same, and that gets 1 deeper, and but it doesn't change the ordering. Right? Everybody good? We got any minutes left, or should we stop? We got time. All right. So now let's think about how to insert something, right? So here we insert 2. So how do you insert? You find out where it goes, and right, you go down, down, down. Oops, here you go down, 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 and we insert it. And then you start coming back up again. And as you're coming back up, you say, hey, I've made this side 1 bigger, right? And so you check, does 3 mind that it's gotten 1 bigger, right? Because 3 has stored its -1 plus 1 minus 1, right? So coming back up, you can say, hey, 3, how are you feeling about this 1 bigger? You update the 3's green number. And then now 3's gotten 1 bigger. So you come up and ask 4, how do you feel about it? And you keep going up until you find, oh, 7 is the first person that cares, right? Everybody else didn't mind that it was getting 1 bigger, but 7 cares, right? And then what do, right? This is height 3, this is height 1, right? So what are we going to do is we're going, that now the balance is off. So it's no longer an AVL tree. So we're going to take the edge from 4 to 7, and we're going to rotate it, right? And we take those trees, and we hang those trees where they belong, right? Does that make sense? And then you say, hey, does everything balance? And it turns out that, right, node 3 wasn't upset before, so it's not upset anymore. It's still not upset. And node 4, right? So you kind of pay attention to how things happened, and everything gets fixed. Yeah. My story, from remembering I've taught this before, is that insertion sort, when you're inserting, you go up till you find the first mistake, and then you fix the mistake like this, and everything's good. It's just one rotation. But when you're doing a delete, right, we did weirder things, and a delete, you might have to do 2 rotations. All right? Everybody kind of buy this? So what's the moral here is, right, so let me just tell you what's been on tests before, right? These algorithmic things have been on tests, right? I could give you, we could give you this tree here. This has been on many tests. I give you this tree. Maybe I tell you the green AVL numbers, right? And then I say insert 2, right? So you find where 2 goes and you put it there. And then you have to do a rebalancing, right? So you have to go up and see who's the first guy that's upset. And the upset is happening between 7 and 4 is the upset, right? The upset is because 4 got to be 1 bigger than it was before. And so this used to be 1 bigger, and now it's 2 bigger, right? So it's this edge that you're rotating. And when you rotate that edge, right, you come over here. Now, let me tell you how I do rotations. I know the book and various books and various people do it slightly different, right? The way I do it is I rotate the edge. You see how 7 was the parent, and now 4 is the parent, right? So I just focus on this. In fact, I think the other ones don't focus on the edge, right? So I think this is Jeff's method. You focus. It's not what they say is node 7 is rotating right? I don't do that. I say it's this edge that's rotating, right? And so this edge goes from this edge to that edge, right? Everybody see how this edge is rotating? And then you say, who are my subtrees? And I'm not changing those subtrees. I'm just putting them where they belong, right? Does that make sense? I think it's an easier way to explain it, but you can see how, other people do it. Boils down to the same. All right, are we good? I bet we've run out of time now, more or less, 2 minutes. Anybody have any questions for 2 minutes? All right, so this is, the test is next Monday, right? All right, so this is our schedule. What you need to do is study. And the way I would study, personally, is I would go to my slides, and you know how things come one at a time. Before you hit the next button, you think, what's coming next, right? So that way, because it's always sort of question, answer. Also, you can do these review things. I haven't actually looked in these for a while, but this was my midterm the last time I taught the course, or maybe the time before that. Yeah? It's everything up until here. See how it says midterm to here? So let's look at what we have, right? What did we cover? We covered abstract data types, right? Then we covered pointers, right? Then we covered loop invariants and all these and all these were all I put all together because they all had to do with maintaining either a loop invariant or a data structure invariant, right? Yeah. Good question. Very good question. So Jackie, they're all multiple choice. All right. Jackie does multiple choice by getting people on E-class. And so they need a special room. They need to go to the computer room, right? We're not doing that. Have you ever used CrowdMark? What is it? It's called CrowdMark, I think, right? You use CrowdMark? I'm going to ask CrowdMark. CrowdMark is going to give me bubble sheets. Bubble sheets, CrowdMark marks the bubble sheets, right? So basically, the evening after your test, I will give them to the CrowdMark, and CrowdMark will mark them. All right. So where is the test? It's in here with bubble sheets. All right. Good question. Any other questions? Right. So we do that, and then we had running time. Right. What did I do here? I did some various weird things. Remember amortized time. We did classifying functions. We did adding. We did quantifiers. Yeah. Yeah. So for running time, what do you need to know? I mean, we'll do a review class next time, but you need to know, for example, that this marker doesn't work. You need to know that n to the O of 1 is what? It's the class of what I call polynomials, right? Because it's n to some constant, right? 2 to the order n. These are what I call exponentials, right? You should know these. You should know, right? That's kind of what all this stuff is doing. It's all building you up to those big classes, right? This is how to talk about those big classes using this. This is how to add those functions together. And you know I love quantifiers, right? Everybody good? And then what do we down here? We have recursion. What are the examples? We spent quite a bit of time on the knapsack problem, right? We covered it here, and we covered it on the test, right? And then you need to be able to solve recurrence relations, right? And you need to understand, we did quite a bit on recursion on trees, right? And then we're getting down here. What do you know? You need to have what is a binary search tree, and a little bit about what does it mean to be balanced, but not right? Not deletions or insertions, right? And not AVL trees. So really just binary search trees, which we did earlier, right? Everybody good? So study those between now and Wednesday. Wednesday, we'll see what slides I have in my review slides, and then life will be good. Come and talk to me. Let me turn off the mic.